Ken Weller here with New Tech Inventors. Tonight I'm going to go through the processes in taking an idea, doing prototype work, and coming up with a final product. Okay, on this table, these are all prototype parts. They're prototype parts for an exhaust fan that can be attached to the helping hand and used for extracting the fumes from the soldering process, the rosin and the solder itself, the fumes from it, which are not good for you to breathe to begin with. So we wanted a way to extract those fumes, and I started out with a couple ideas. I started out with these larger fans, this size right here, which is an 80 millimeter. The first thing I had to do, I had to have a way of attaching these to the helping hand and attaching them to a flexible device so I could position them the way I wanted. So I started working with prototyping these parts, and they were designed so that this would snap into it and lock in place. Then I could use this, and then the fan would then attach to that. So that would then give me a mount. But once I get it mounted and get it attached to the fan, then I decided I needed some shrouds. So I started printing these different sizes and shapes of shrouds for intake and for exhaust. And for the exhaust, I thought at one point I might just have a long tube to carry the exhaust fumes away from the work area. The shroud, I would need some kind of a shroud to be over the soldering work area that would actually pick up the fumes from the soldering process. So I came up with these different things and started experimenting around, and then I would take my power supply over here and I would hook up power to these fans, and then I would test to see how much flow I had going through here, and then I would actually mount them and take some solder and a soldering iron and some rosin and create smoke to see how well this would extract the smoke and collect it. So in the process, first of all, I had to make sure that once I had a fan, I could make these parts to fit and interlock with it, like we're doing here, where these bolts can go through, and that also these different attachments could come off and be exchanged with others put on here. So that's part of the process, making these little pieces to fit over the end and fit snug and tight, making them so that they'll attach to this corrugated tubing where I can use it to extract the fumes and so forth. So that's part of the process that I go through in prototyping and coming up with ideas and trying them out. And there's a lot of trial and error in testing these things. You have to try different shrouds. As you can see, these are different sizes, and you try doing them different sizes and stuff to see how well they draw the air. On the exhaust side, the more you restrict it or limit it to a certain size tube, the more trouble you're going to have drawing in the smoke from the soldering process. So those are a few of the things that I encountered here. Now, one thing, once I got this and mounted it to the helping hand, I found out that once it was mounted, it was pretty big and bulky. However, it would mount and hold its position somewhat, but it was awfully heavy and somewhat awkward. So I thought what I need to do with this is use this for a fixed station. So I'm working now on coming up with a stand or something where this device can be set up separate from the helping hand and not actually be an attachment hanging off this boom and trying to position it. However, we may have a version of it once I get it perfected and everything, a larger one like this, that we'll use and sell with the helping hand. That said, I came up with another idea. I thought, well, what if I can come up with one with the helping hand that's a little less expensive, a little bit easier to work with the helping hand and so forth, because by the time I came up with this and included all of the parts that were going to be necessary to make it work, it was becoming a little bit expensive for an attachment for the helping hand. So I thought, well, let's come up with a micro version of it. So now we needed something a little bit smaller, portable, that we could use better with the helping hand in a flex arm attachment. So I started experimenting around and came up with some smaller fans, various sizes, and I found that this particular fan, it's a 40 by 40 by 20 millimeter fan, I found that it would work pretty well. So I took this fan and I made this particular housing for this fan. I run that wire into that area, and then that fan just slides and fits right into position there. Okay, then this will attach to our flex arm. Now we've got a flexible fan, and we can run our power through here. Okay, the next thing I wanted to do was, again, I was going to need some shrouds. So I printed some different shrouds, various sizes and shapes, and figured that I would use these shrouds to go on here and get them in position and just slide the bolts through like this. And then I could put a different shroud on the other side, and the bolts would go through it as well, holding it in place, which is basically an example that I have right here. Okay, so in doing that, there were a couple obstacles. First of all, I had to make sure that I got the right dimensions for the shrouds and everything to work together, and for the fan to fit in there. Then I had to have a chamber. In some of the earlier prototypes, this chamber, as you can see right here, was very small, and it did not leave enough room for the wires and connections that I needed. Plus there's a switch that goes in here. So I modified it and made it larger. As you can see on this one, that chamber is much larger than it is here. So I had to make that change, and that's part of the prototyping process, is just trial and error, trying things and seeing if they work. And in this particular one right here, you can see we've got the switch wired up, but it won't fit in there because it's crowding the wires too much. We're afraid we're going to short something out if we try to force them in there. So that prompted me to go to this larger size here. So we've got 60 or 70% more space there now. So we should have plenty of room for those wires to tuck in. And of course we had to increase the size of this switch plate. So here again we're experimenting with these different configurations and different nozzles and baffles and so forth, trying to figure out which ones will give us the best intake and exhaust and so forth. Okay, so coming up with this smaller, flexible, lightweight 40 millimeter fan on the flex arm to use with the helping hand, this would be a lot more practical, and it would allow you to get up close to the soldering area and exhaust the fumes and so forth. But unlike the larger version, where I was considering actually having a hose or something carry those fumes away, I thought, well, maybe there's a way that I can do some filtering. So as you can see on this one, we have the setup and we have a filter on here. So I thought, what kind of a filter can we use? And I looked at different things. I looked at filter cartridges that I could purchase and make filters. And then finally I found this filter for an air compressor. And it had a piece of foam in it. Well, that would work pretty good. That would help, but it's not going to help a lot with some of the fumes from soldering. So what I did, I took this foam out and cut it in half, made two parts. Then I would put one part back in, and then I thought, well, I'll put some activated charcoal in there. And I was thinking, well, if this thing's on its side, the charcoal could go all to one side. And how do I get it in there and regulate it? Well, I came up with this little piece here that I 3D printed. That's a spacer. And you can see I'll have a little less than 1/4 of an inch of space for the charcoal, and that fits right down on top of that foam pad. Then I would take my charcoal and let's see if I can pour this in without making a big mess. Okay, that looks like that filled it up. Of course, it covered the table also. And I spread that charcoal around in all of those chambers. And then as you can see, the charcoal is now in there. Then I put this top piece of foam back on it. And then I put this cover back over that. And lock it into place. And I snap that back in place there. And now we have a filter with two foam filters sandwiching our activated charcoal. So now when I put this on here, and this one already has the activated charcoal in it, as the air is exhausted through here, we're filtering out those contaminants and a lot of that smoke and so forth. So now we ended up with an onboard filter, and this filter just screws on here, and now we have the filter and everything all self-contained. So all you have to do is position this, and we'll have different types of nozzles and hoods or shrouds to be able to pick up the fumes and then exhaust them through the filter, and then you're actually breathing filtered air. Then another thing that this does is when you reverse the situation, if you're using this fan for painting miniature figures, miniature soldiers, or anything small, models, and so forth, and you're wanting that paint to dry and you don't want any lint in the air to affect it, then you can reverse the flow and have air coming out of this onto the area where you're painting, and it's filtered air, so any lint in the room will be filtered out, and the lint won't be falling on your paint because this filtered air will be blowing on the surface and blowing anything away. So it can be used for drying when you're painting or gluing or whatever. And the filter would be good if you're painting to make sure that you're not getting any particles, hairs, or fibers or anything in with your paint, especially on those small figures. So that's a couple of ways this thing can be used. Now, putting it on here as an attachment, you don't want this fan running all the time. So if you're not soldering, I didn't want to have to unplug it from one of the ports every time. So I thought I would put a switch on board. And I'd mentioned earlier that the area where the switch goes, which is right here, then you can just flip that switch on and off to turn this thing on and off. Okay, then I couldn't quite stop there. I started thinking, okay, this will make a good attachment for the helping hand. We've got our light attachment and so forth. But I also thought there might be some applications where we could use this as a standalone device, where all it does is filter when you're soldering. So I thought, well, if I do that, I've got to have some type of a table mount. This is what I came up with. I have the regular unit with the filter and the switch and the intake and so forth, but I made a base for it. And I thought this base isn't very stiff, so I found some cast iron flanges that were less than $1. So what I did, I ran my wire, put a hole here, and I threaded this hole so I could thread this helping hand device into it. And then the wire goes down and comes out the side here. So once I get the wire in there, then I simply put this flange over here and snap it down into there. Then I've got this cover piece that goes over that, and it goes down. And then I can pull this wire through, and I can turn this a few times counterclockwise, and then start screwing it in clockwise. That way I'm not over twisting my wires. Okay, so now I've got a table mount. The problem with this is that it's still a little unstable. It's not as stable as I want it to be, so I have to do one of two things. Either I have to shorten the flex arm so that it can retain balance, or come up with a different base. I can make this base a little bit wider. The wire that comes out, of course, I've got some of this corrugated tubing. There'll be a connector on the end of it, but right now I just have the bare wires. And then the connector from the end of this will have its own transformer and operate as a standalone unit. Now I'm going to put some power on this one. Okay, I've got the power on it. And then I can flip my switch and it starts blowing and drawing air in, doing the filtering process. Now, in addition to that, if you notice, there are two little LEDs here. I thought, well, if this is standalone and it doesn't have the helping hand to help when you're soldering, it might be nice if it had some light to help light up the work area. So I added those two LED lights to it, and of course they come on and off with the fan. Now, a little bit about the switch. I had to put a switch on there, and I had that compartment that had the compartment that we enlarged the area, and I made this piece to go over it that snaps in, that holds the switch. And then the switch goes in and of course operates. Now there's a flange with a couple holes on this switch. I didn't want to have to deal with putting screws in or anything, so what I did when I 3D printed this thing, I 3D printed two little tabs here that stick up. And as you can see here, I've pressed those two tabs through the flange holes on this switch, and that's mounted the switch. And to make sure that they don't come loose, what I do, the last step, I'll take a flat tip soldering iron and I'll melt that plastic down flat on each side, and that holds that switch in there where it can't go anywhere. Then we just have to solder it to the wire connections that we have in here, and then push the wires back down in that chamber and snap this switch in. Now, as far as holding the switch in, I haven't decided. Right now it snaps in and holds pretty good, but I haven't decided if I'm going to try to glue it or come up with something else that will help hold it in place. I've got a couple options, but we're going to still have that to resolve, but that will be pretty minor, I think. So we got the electrical, the switch thing worked out. We came up with a way to mount these by having them where they will snap into these flex arms, and we came up with a lot of different flanges and so forth to experiment around with. Some of the more recent ones that I'm experimenting around with that I'll show you, I've just printed a couple of these. This is one of them. You can't really see too well here, but I actually put in blades in there. You may be able to see on this one, and those blades are so that when the air comes through, it's forcing the air to kind of circulate in a specific direction. And the reason for that is because when the fan is running, it's creating quite a bit of airflow until you start putting these shrouds and restricting it, and then that energy has to go somewhere, and you've got some blowback on this fan. So I'm going to experimenting around with some different pieces that could go on here that can help reduce that blowback and force more of that air to go through the nozzle. So right now there's a lot of trial and error, experimenting around with different vanes and pieces, but that's where the 3D printer comes in good. All of these pieces that you see here were printed on a single KP3 printer that I have in my office, where I sit there and do this prototype work. It comes up with patterns for me and different little gasket devices and stuff, and I can actually print these things and try things and make changes and have something else printed. I have 4 of the KP3s in my office and 1 KP3S, so I have enough printers there that I can keep up with my prototyping. By the time I make a change on the computer, parts usually finishing printing. A lot of these parts take anywhere from 30 minutes to 2 hours to print. So that's what I wanted to show you. I didn't go into a lot of detail on some of the stuff where we're just, like I said, still in the experimenting stage. You can see there's a lot of different ways to put these things together. So this is what I go through when I come up with a product. And before I put a product on the website or on Amazon, I will go through a lot of experimenting and testing and so forth. And one thing that I really think is going to work out well is this charcoal filter. Now, I purchased these filters. I think they're roughly around $2 a piece, the way I'm buying these. However, in the near future, once I get the shroud worked out, I'll be 3D printing a shroud that will have a chamber like this in it, and I'll be doing my own filter. I'll just have to go buy some of that soft filter foam and be able to cut it into a circular, which shouldn't be any problem stamping that out, and make my own filters. And I should save a little bit of money there doing that. That's the name of the game, coming up with different ideas, figuring out what you need to do, adding lights to it. I'm now going to have these lights on all of them, even the flex arm, because it sure can't hurt. I think the biggest challenge is trying to come up with the most efficient airflow and using different chambers and so forth, and shrouds, intake and exhaust, to be able to control that. And right now, to use this filter, I'm having to taper down to this diameter from a 40 millimeter down to probably about 15 millimeter, 16. That's a lot of restriction. When I come up and make my own filters, incorporate them into the shroud, I won't be tapering down. I'll be going directly into that, which will allow a lot more airflow, put a lot more suction on this end, and will do a more efficient job of exhausting the fumes. So those are my thoughts right now and where this thing's headed. You should see this product going on my website, and you also should see it going on Amazon pretty soon. And that will be the flex arm attachment for the helping hand, and also the standalone device like this. The larger one, it may take me a little longer to perfect it, because I think it's going to have some special applications, probably a little more on the commercial side where you really have a shop doing a lot of soldering. I think I can configure this one to where it can do a really good job in an environment like that with those larger fans. So remember, prototype, prototype, prototype. Just keep trying until you get it right. Sooner or later, you'll get it right, and when you're happy with it, then let's go make some money. So until the next time, happy printing from New Tech Inventors.